All right. It's 9:02, so I think in the interest of time, we'll get started. Good morning, good afternoon, everyone. Welcome to today's webinar. I am super excited to bring you another topic today. Today's session is a little shorter than usual, like we do it 60 minutes usually. Today we're doing it 45 minutes just to focus on one particular topic. So I'm very excited to have a very special guest today. There's a celebrity product leader with me. I'm honored to have him on the call today with me, Jason Reed. Jason, do you want to introduce yourself?
Yeah, thanks, Kundan. So I'm Jason. I'm a product manager here at Databricks. I oversee our storage and cataloging efforts. So open table formats like Delta Lake and Apache Iceberg, and Unity Catalog and various integrations with products like StreamNative. I was previously a co-founder at Tabular, so an Iceberg-based lakehouse platform, and then prior to that, I spent 8 years overseeing data engineering at Netflix, where the Apache Iceberg project was born. So it's really cool to see that technology has evolved to the point where we're talking about it today with streaming and integration with platforms like Databricks and StreamNative. So excited to be here. Thanks.
Awesome, awesome. Welcome, Jason. All right, so let's get started. So we have only one topic today, so I think we're gonna really focus on going a little deeper into this. So Jason is going to get started talking about Apache Iceberg REST catalog and all the details around that. I'm going to then cover StreamNative's integration with Iceberg REST catalog, support within the Unity catalog, and then I'm going to show you a demo if everything goes well. So we'll keep it light. That's the only topic for today. So let's get started. So Jason, over to you.
Yeah, so I wanted to start with like a little bit of background context. The notion of a catalog, the word catalog is an overloaded term in the data space. And so I want to be a little bit more specific about what we're talking about here. The Iceberg project, when it was, first open sourced, it actually didn't have like a catalog interface the way we think about it today. But I think quickly, Netflix, we realized that having a catalog was really important for a couple of key pieces. One is, just discovery, like a place to be able to see like what tables do I have, what are the schema of these tables, those challenges. And the second thing was being able to ensure we could have, atomic coordinated changes to those tables, even if they were coming from multiple different compute engines. So at Netflix, we were primarily dealing with open source engines like Flink and Spark and Trino. And we had all those engines interacting on the same data sets, and we wanted to make sure we sort of had those asset properties. And so the catalog became a key piece of the design and the architecture. But because we were coming from sort of that classic Hadoop spaced infrastructure and architecture, we had a Hive Metastore at Netflix, and so the original Iceberg catalog was actually just kind of a hack on top of the Hive Metastore, to be honest. And that got us some way. But when we left Netflix to start Tabular in 2021, I think one of the things we first quickly realized was if we were going to have a sort of Iceberg SaaS-based product, it needed to have a more flexible cataloging interface that any engine could connect to that wasn't tied to technologies like Hive or Hadoop. And so we introduced the Iceberg REST catalog, specification into the Apache Iceberg project. And it's been really great to see that, obviously the Apache Iceberg table format has taken off a lot in the last couple of years, but similarly that REST catalog specification has really become also kind of an industry standard for how different platforms, open source technologies, as well as commercial platforms, interact with data. And so when you're thinking about an Iceberg catalog, and in particular, there are many Iceberg REST catalogs that are available in the marketplace today. There's obviously open source ones like Apache Polaris, but there's a number of commercial ones, Unity catalog from Databricks being one. Many of the hyperscalers also have their own flavors of these things. And so as a customer, like what should you look for when you're thinking about an Iceberg catalog to choose? And these kind of the three key pillars that I talk to customers about all the time. The first one is, hey, it has to deliver on this promise of Apache Iceberg interoperability. So it needs to be fully open for reads and writes, not just from some sort of proprietary engine, but from any engine that speaks the open source protocol. So you want to be able to stream into it from platforms like StreamNative, and also then turn around and read that same data from a tool like Trino or Databricks. The second thing is you got to have not just the basic table maintenance that the Iceberg requires. So this is like compacting small files and cleaning up old snapshots that are no longer needed, but more advanced table optimizations. I think we're past the basics, and customers should be expecting more advanced table optimizations from their catalog layer. So this is things like understanding the different read and write patterns, being able to stream data into a system, efficiently at low latencies, but then also run big analytic batch queries because behind the scenes, that storage layer is being optimized for both stream inputs, but then also analytic type analysis on the other side. And then, the last one is to make sure that you can interoperate with other external catalogs and systems. For most of our customers, enterprise customers, they don't have all their data in one place or even in a single catalog. And so you needed to be able to do this federation capability. You need to be able to reach out and talk to other systems, and so you can have a singular view of everything in your data estate. So those are kind of the three key pillars. And then take the next slide and talk a little bit more about how we address those three challenges at Databricks, specifically with our Unity Catalog product. So Unity Catalog is our cataloging offering from Databricks. It's been in the marketplace for a number of years now. It's quite a mature catalog. And most recently, since I joined Databricks just over a year ago now, we've enhanced it to have these Iceberg REST catalog, APIs and be really interoperable with the entire Iceberg ecosystem, which has opened up a lot of new avenues for our customers and for partners like StreamNative, which we're excited about. And so it's absolutely open. You can use our catalog product with any of the open source APIs. This is true of we have obviously a hosted commercial version, but we also have an open source version of Unity Catalog. Both are interoperable with the open source APIs of both Delta Lake and Iceberg. If you're using our hosted version, then we offer all those table optimizations that we talked about. And we'll talk more about exactly the specifics of those in a coming slide. But we also offer the capability of federation. So you can connect your Databricks Unity catalog to other catalogs you might have, to existing Hive metastores, hyperscaler catalogs like Amazon's Glue product, or even things like Snowflake Horizon. So double clicking into that pillar around optimization. This is a pretty unique offering in the market that we have at Databricks with our Unity Catalog product, which is not only can you read and write to it, obviously, from all the Databricks compute environments, but you can read and write to it from any engine that supports the Iceberg REST catalog protocol. So obviously today we're here talking about StreamNative and their interactions with this catalog, but this also holds true for lots of other tools in the ecosystem. And even if you're not using Databricks Compute, so even if you're using StreamNative to write data into these Iceberg tables, we fully manage them. We provide access controls and governance on those things, as well as doing the AI-powered predictive optimization. So this is looking at your query patterns and understanding how you're using the data, and then physically reorganize the data on disk, sort of clustering that data in a way that really optimizes your downstream queries, so that given a given query, you can read the least amount of data possible. So that saves you money and makes your queries more efficient and faster. So sort of everybody wins when we optimize that storage layer. And just get one more deep dive into how we do this. This reduces the total storage size in your object store, and we use a technique called liquid clustering. So this is like a more advanced version of partitioning, which is sort of a very crude way to organize data on disk. Liquid clustering is much more fluid, adaptive, it's dynamic. It can change over time as your table evolves, as your query patterns evolve. You don't have to think about, are my partitions correct? Do I have the right granularity? Do I have skew? Do I have too many small files? All of these problems that we historically had with sort of the classic Hadoop style tables and Hive style tables, we solve through a combination of using Iceberg and applying these liquid clustering techniques. So again, even if you're using StreamNative to write this, stream this data into your Iceberg tables, if you're using Unity Catalog to manage those, you're going to have great performance in all your downstream queries, and you don't have to think about it. It all comes out of the box, and You'll see some pretty cool demos of how simple this all is. So a lot of complexity that is hidden under a really nice, simple interface. And then the last thing I'll say before I hand it back is, we've really focused in today's session on the Iceberg tables and all the optimizations that we can do. But actually, like our catalog product covers a lot more ground. Like I said, it's been in the marketplace for a number of years, and it meets a lot of enterprise needs. Things like lineage, things like cost controls and auditing. Really advanced access controls and security and governance with row-based filtering, column masking, attribute-based access controls. All those things are available, and they can be applied to tables even when they're being created and written to by external tooling. So like a really powerful, really open ecosystem, and really that separation of compute and storage taken to maximum value and flexibility for customers and partners. So with that, I will hand it back to Kundan.
Awesome. Thank you so much, Jason. I think that's really helpful. So just continuing on that thought, like the context which Jason has set already, I want to talk particularly about StreamNative's integration with Unity Catalog. And I have covered this integration before in the context of Delta tables, the ability of StreamNative to stream data, topics data as Delta tables and publish them in Unity Catalog. Today, we're going to talk about Iceberg tables. So you can just use the native integration to stream data as Iceberg tables in Unity Catalog. So the ability to stream data to a lakehouse like Databricks, Unity Catalog, is built in within StreamNative Cloud natively. So we can natively integrate with, in one of the slides before, Jason showed like some of the native APIs which are used to interact with the to create and manage Delta tables or Iceberg tables. And then he expanded on the Iceberg REST catalog, right? So essentially, those capabilities are all natively supported. Today, we will talk about the Iceberg tables interaction, particularly, which is based on the Iceberg REST catalog API integration. So essentially, when you configure your StreamNative cluster, you can configure the details of your Unity catalog and all the credentials. And then at runtime, essentially, it streams each topic as an Iceberg table and publishes that into the catalog. That whole interaction is happening via the Iceberg REST catalog API. So I'm going to talk a little more about that as we go along. So I think I'm just on a very high level. I'm going to just talk about, the flow between, I must have shown a very similar flow, a similar diagram for Delta table interaction, but here there are some differences between how Iceberg REST catalog API interactions work. So you would basically, once you set up at runtime, when the interaction starts with the Databricks Unity catalog, you sort of, for each topic, we want to create a table if it does not exist, right? And then we write the data as Parquet files. And then I think, as we support sort of the unidirectional ability to kind of write data and append data. If the table does not exist, we create the table. If the table exists, we can add to the table or append to the table. Over time, we might actually support the upsert operations with Iceberg v3 support, but that's something which we will talk about as we get closer to that. But we follow a simple kind of interactions model based on the Iceberg REST catalog API to ingest topics as Iceberg tables. And by the end of snapshot 4, basically like that table and the information is already published inside the catalog, right? And one thing I want to highlight here is that basically, as we use the credentials to interact with their Wix Unity catalog, the REST catalog API tells us where the storage is and where we need to write. So that makes it even more easier for us to kind of manage that life cycle. Okay, so I'm going to just show you a little bit about how it looks in the UI, and then I'm going to show you a quick demo. So when you create a StreamNative cluster, you enter all the cluster details. Essentially, you will have a section where you can configure the catalogs. So the first step is, for the folks who are not familiar with this, We basically have two storages here I want to highlight. The first one is really the storage for storing the data as we receive it quickly from different sources. Because we are a streaming platform, we want to make sure that that data is available for consumption from consumers or other connectors. So we store it very quickly. So imagine a lot of small files in a storage bucket, a general purpose bucket, where essentially we are reading the data and storing it. So for this, you can use a StreamNative provided bucket or your own bucket. So for simplicity, I'm using a StreamNative provided bucket here, and you can see what the location of that would be. But then the next thing is enabling the catalog integration. So this is where the interaction with actually Databricks comes in. So you see two options, and my apologies for the small screenshot here. The first one is Databricks Unity Catalog for Delta, and this one is Databricks Unity Catalog for Iceberg. So you choose that to stream your topics data as Iceberg tables. You select that, you enter the name of your catalog, and then the URI. The schema name is automatically created based on a naming convention followed by our cluster name, tenant name, namespace name. I'll show you that as we go along. And then you choose the OAuth or PAT. Right now, PAT, this is the old screenshot, I'll update it. But essentially, we'll support PAT as well. So once you configure and deploy the cluster, the runtime will start, writing data basically to catalog. So jumping into Databricks, what that would look like, I configured in the previous screenshot, right? In the previous slide, I showed you the catalog as Unity catalog for Iceberg. This is the catalog and this is the schema. So it's like a combination of our sort of cluster name, tenant, and namespace name. Automatically, it'll assign that. And then these are the topics which existed in StreamNative cluster, which automatically start showing up. And I'm highlighting that on the right. Basically, once they land here, you can expect them to be seen as a managed Iceberg table, right? Within Databricks. So we'll see more as we go along. Just one or two more screenshots before I go to the demo. Essentially, I'm just showing within StreamNative Cloud, as you see a topic, that topic will go to a storage, right? This is a storage kind of managed in a by Databricks. It has full ability to read and write data, as Jason mentioned, on the storage location. So this is where you can expect to find all the manifest files and the data files at Parquet. And I'm just showing an example of how a table, a topic, is lands as a particular folder and a bunch of files within a storage bucket, and which eventually kind of shows up in Databricks as a managed Iceberg table, right? Um, all right, just these are just some more screenshots of how things that can be expected once you configure your storage bucket with. This is a storage bucket you actually configure. I should have mentioned, I forgot. The storage bucket you configure inside Databricks as an external location. And when I do the demo, I'll show you that. So StreamNative runtime automatically gets information about this bucket, and then it can sort of ingest data to that, right? So this is just a couple of screenshots of how it would appear. Okay, so I want to show you a demo now and to see how that actually looks end to end. So this is the demo scenario. I thought I'll add one more component to it, which is our Unilink thing, Unilink product, which is a replication tool. So here's the flow actually. So typically you would stream data into StreamNative cluster, right? Through different sources using your connectors or your custom applications like producers, and that streams data all the way down, right? But today I want to use another tool just to show you that. Uh, it's called Unilink. It's been out there for some time now in public preview. It's a built-in capability in StreamNative Cloud to replicate data from different Kafka clusters. Today I'm just going to use Confluent as an example, source Kafka cluster. So I'll replicate a topic from Confluent called products info, which will show up in StreamNative. The data, the schema, everything will show up. And then automatically the configuration, the catalog integration with Databricks Unity Catalog will stream that topic as a table. And I'll show you how that object storage looks like, and then we'll query the data in Databricks, right? So that's the flow here. Yeah, that's what I wanted to cover. Let me just jump now. So I'm going to start from the left to right? So let me just go here to the first environment, which is Confluent Cloud. So this is where I have a cluster running and I have a topic, and this is products info, and it's got some data here. Um, and it's got a bunch of fields. I'll give you an example of how the record looks. So this is how it is. And then this is the schema. It's an Avro schema. It is also kind of registered inside the schema registry within uh, Confluent Cloud, right? So this is our source. Okay, now let me go to StreamNative Cloud. So here I have a replication tool running already. So before our session, I kind of created a data migration job and a schema migration job, which basically is replicating all the data which is coming from the source cluster. So since this is already running, let me just quickly show you what that looks like. So this is the source cluster broker details, and this is the destination cluster ID where it's going to go. And then typically it shows, like right now, it's not showing any active information. Actually, let me just try to see if I can populate some more data. So I'm just going to ingest like maybe 1,000 records or so in the Confluent cluster. This is going to Confluent topic, and then this will replicate it from there. Anyways, let's come back to the flow. So that's basically the data migration job, and then this is the schema migration job, which is going to replicate schema from the schema registry broker details here, right? So I'll quickly show you without spending too much of time what this looks like if you have to actually create these jobs. So you can say data migration job, and you can choose your source cluster, enter the broker details, the authentication details. And then as you go next, you choose your destination StreamNative cluster where you want the data to be replicated. It basically validates this, and then if everything looks good, then it lets you move forward and choose your topics from the source cluster and replicate it, right? Same thing with schema migration. You can choose your schema registry, and as you create the job, and it basically lets you replicate all the schemas or selected schemas based on wildcard. Okay, so those are the tools. Let me see if it is going to show you anything. See, right now it's migrating the data which I populated into Confluent. So I think you can expect to kind of see that in the topic. Let's come to now quickly the main part of the second part of the demo. The first part was really replication, and the second part is the main part, which is today. Whereas the data comes into StreamNative Cloud, we stream it directly to Databricks. So I want to show you that part now. So I think this cluster, again, just in the interest of time, I configured this cluster already to point to a particular Databricks environment. I'm using Databricks free edition. I'll show you that shortly. And I've configured the catalog here. And so now this cluster is already configured to stream data to this destination and as a Iceberg table format. Okay, so I'll show you that just in a second as to how you actually do. So before we go to the topic, I want to show you, the experience. I will not create a new cluster now, but I will show you the user experience. So right now, this catalog integration is only available in our BYOC offering, but over time, you can expect to see it in serverless and dedicated as well. So as you go through this experience, I'm just showing you the experience of creating um, a instance in a cluster. So I'm just going to say demo cluster. And this is the UI I was talking about. I'll choose an existing bucket to store data as it comes into StreamNative cluster. This is not the storage bucket where Iceberg tables go, because that information comes to the runtime via the Iceberg REST catalog APIs. Right? So user doesn't have to configure them. User configures them in Databricks. Anyway, so here you enable the catalog, you select Iceberg as an option, and you enter sort of your catalog name, and then maybe the URI, and then you enter your principal, the secret which you create in Databricks environment, right? And with this, basically, the cluster starts running, it starts replicating your data, streaming your topics data as Iceberg tables. So I'm going to come out of this because I'm not creating a cluster now, but I want to show you the cluster which we are streaming to Databricks. So this is the cluster where the Unilink tool replicated the data and I pointed that to this cluster. I showed you this ID if you remember. Now I want to actually go to the topic. So this is a multi-tenant architecture-based system for the folks who don't know much about StreamNative cluster, StreamNative. So it's based on Apache Pulsar, and that is why I'm selecting like instance, the cluster tenant and namespace here. So if I go to topics, you'll see this is the topic which was in Confluent Cloud. And then if I could just get to it quickly. Yeah, so this is the same topic, which is now products info, which is replicated here. And here essentially you can view if any new data has arrived. And this is the same data you actually saw in Confluent cluster. So the data is replicated, right? Now, the key thing here is, I want to see how that data is actually going into Databricks. So let me just go to now, before I go to Databricks, I want to quickly show you something in S3, essentially, give me one moment. Yeah. So I want to basically show you where that data lands. Like there is a storage bucket which is configured with Databricks, which is fully managed by Databricks runtime environment. And we get information about this through the APIs and we write to it. So this is that bucket which is configured with that cluster which I showed you just now in StreamNative Cloud. So here it basically lists all the catalogs and the tables. There was only one catalog I had in the table. And these are sort of the tables representing different topics. And then within them, you can sort of expect to find all the data and metadata, right? So this is really the mapped folder where Databricks is going to sort of interact with and manage. So now I'm going to jump into Databricks. So there is the Databricks free edition, but our integration works with I would say enterprise edition as well and all the other editions. So within the catalog, within the Databricks environment, you can see this catalog was created by me before, and then I assigned all the right permissions to it. I created an external storage location which pointed to that bucket, and I granted all the permissions. And then at runtime, essentially, this gets created. This is the dynamic part coming from StreamNative cluster, which is creating a schema based on the naming convention of the cluster tenant and namespace. And this is the topic which kind of showed up here from the StreamNative cluster, including some other topic which existed. But I want to kind of show you this topic here. This is registered as a managed Iceberg table. And essentially, I can now sort of run quickly a query to show you some data from that. It's the same data which came all the way from Confluence cluster, which was replicated to StreamNative, and then it should be found here. Again, this data is coming from that storage bucket, which I showed you just a minute back. So I'm trying to query the table, Iceberg table, which is within the catalog. And so this is all the information you see there. And let me see the date. Is that? Yeah, so this is 28th of August. So that's the latest data actually you're seeing here. So that's streamed all the way. So that's the flow. One thing I want to highlight quickly though is actually for that I might just go to the slide is we as we stream data to a storage location fully managed by Databricks, it's only in one direction. And as we compact the data, once the compaction is run on that other storage which I showed you, which stores all our data in URSA format, then result of compaction goes into this other storage managed by Databricks. So if there are multiple topics here and for some reason a topic gets deleted in StreamNative, basically then I think it'll not be deleted in the managed, storage environment by the storage bucket managed by Databricks, right? Because that's fully managed by Databricks. But yeah, but if you go to the catalog of Databricks UI and then delete that table, then it'll disappear from that catalog. It'll exist in the storage bucket for some time. I think there's a specific duration, and then asynchronously that gets deleted. So that's fully managed by Databricks. That's why we want to support this model and the pattern. Like we are supporting an external table. For us, it's an external table, and that table is fully managed by Databricks. And the reason again for that is because Databricks is heavily investing in all the R&D around how to optimize these tables. So we want to, of course, like, be a part of that journey with them, and our customers can benefit with that pattern more than any other pattern, I guess. But we're happy to hear from our customers if there are other use cases they are hearing. Yeah. Anyway, so that's the flow, that's the demo, and I'm going to come out of this. That's all I wanted to cover for that Q&A. So I want to share some resources if you want to scan this. These are the blogs. You can also find them on StreamNative blogs. These are the blogs very specific to how we integrate with Databricks Unity Catalog. The first one is I think related to the Delta Lake integration. The second one is related to the Iceberg tables integration. I'm also going to publish another one soon with the latest support we rolled out recently. Folks who are new to StreamNative Cloud, if you want to get your hands on the environment, you can sign up for a free trial. And if you want to book a demo, you want to learn more about it, happy to get on a call and chat with you guys about it. So you can submit a request here. There is a very important event coming up for us, like Data Streaming Summit. This is an in-person event next month. And this was called Pulsar Summit before, but now we renamed it last year to Data Streaming Summit because we've opened it up for all the streaming technologies to come and join and be a part of this event, make it more broader. So that's why it's Data Streaming Summit. So I think if you want to be a part of it, scan it, and then please register for it. I think as a participant, you can still do that. I think the submission for papers is closed now because we already rolled out the schedule, but you can definitely participate as an attendee. We also have a very interesting fireside chat with the co-founder and chief architect from Databricks, Reynolds Zinn. So I think I'm looking forward to that. I think this will be an exciting session to get some insight from the industry leaders. So this is another event on September 30th. This will be right after the keynote. Okay. So I think that was all for today. Let me see if there's any questions, and then we can go from there. Let's see. We have two competing lakehouse table formats. Okay, I think, Jason, I'm going to read out this question to see if we can address it together, or is it, so we have two competing lakehouse table formats, Delta and Iceberg. I see a bigger adoption of Iceberg. Even Databricks is supporting it. Is there any reason to choose Delta Lake over Iceberg? So I think
It's a really good question. It's one I could probably answer since I get it a lot, right? I was obviously, since I've joined Databricks and I was coming from an Iceberg-based platform, and obviously now at Databricks, I oversee both Delta Lake and Iceberg. And the answer is probably not in the fullness of time. We're working on actually converging the two, right? Like having two competing standards actually it doesn't help anybody. It doesn't help Databricks. It doesn't help anybody in the data ecosystem. Everybody has to do double integrations. Even the folks like at StreamNative have to do like a Delta Lake integration and Iceberg integration. And like there's choices in the product that are just confusing for customers. So what I typically tell people is use whatever you're like currently using. Like if you're already using Delta Lake, there's no reason to switch off of it. And if you're already using Iceberg, same thing. If you're just starting out, then pick whichever one is like closest to the technology set that you're working with. But it really shouldn't matter long term in the sense that we are bringing these things together and we're converging them. So you might have noticed even in the demo, even in our managed Iceberg table, if you look in the S3 bucket that Kundan showed, you actually saw like a Delta log folder in there. That's actually because we're generating both Delta Lake and Iceberg metadata for all the tables. So actually, regardless of which door you come through, the Delta door or the Iceberg door, that all works the same inside Databricks. So we're already doing the translations behind the scenes. As we get closer and closer to converging the formats, we won't have to do that translation anymore. But our stance is that customers, it's a false choice. Like it shouldn't matter. You use whichever one you want. They give you the same benefits. Hopefully that answers the question.
Oh, that was great, Jason. Uh, I'm sure it did, and I think I definitely align with that vision. So there's a lot going on in that space, and we are also constantly keeping an eye on how the vision here is expanding, and just for the greater good of the developers and the community. And then we are trying to adopt and integrate with the right mechanism as Databricks kind of rolls that out, or the broader open source community of Iceberg and Delta kind of work together. So yeah, exciting times. Okay, sounds good. I think I just okay, there you run. I have one more question. How to run compacting when streaming the data into the Iceberg table. So right now, maybe this is more for me, perhaps for the in the context of StreamNative integration. So I would say compaction right now is kind of done by us. We don't ex we give we're going to make this a little more configurable over time. The only sort of choices right now we have is like how soon do you want the compaction to happen? Is it based on time duration, or is it based on the storage or file sizes and things like that? But I don't think we have a mechanism where exclusively as a user you can choose when to compact. But I think those are the two parameters we have today. They're not exposed in the UI in the cluster. That's something we can explore doing. But we'd love to hear if there are other sort of use cases around how having a control on compaction can help. But right now, these are the two parameters we have behind the scenes if you want to use, but not in the UI.
I'll follow up that. So like there's two sort of compaction things happening, right? There's
I
the
see.
stream data that gets compacted and ultimately lands in the Iceberg table. And then subsequently, Databricks will maybe further compact if necessary, right? So let's say you want relatively fresh data in your Iceberg table. So you are saying, hey, every minute I want to, compact data from my stream and put it in my Iceberg table. That gives you a lot of freshness, but you may still end up with a lot of small Parquet files. But if it's again, Databricks will automatically compact those over time for you as well. Into, eventually for analytic use cases, you probably want, at least, multiple megabyte size files and not kilobyte size files, maybe hundreds of megabytes if it's a large topic and a large table. But we'll sort of handle tuning all that for you. Even like growing that file size over time as your table grows. Like we're really quite intelligent about how we lay out data for batch analytics, even if it's coming from a stream. So in a perfect world, you won't have to think about it, and you'll just get great performance kind of regardless. You can also like manually in Databricks, if you want to, you can run optimize command on the table and it will sort of force compact. But typically our customers don't need that. The intelligence in the platform kind of handles it.
Awesome. Awesome. Hopefully that answered your question there, because I know I was attending. Okay, that's great. I don't see any other questions at the moment. But yeah, this recording will be available to others, and then of course, we'll keep you posted on any other events which are coming up. Right now, Data Streaming Summit is there. I know Jason is doing a lot and a lot of Iceberg meetups and other events as well. So I think you can, explore more about that. But I would thank Jason again for being a part of the session today. It's really helpful. Thank you so much, Jason.
Yeah,
And
thanks for the invite. And like again, I hope people can appreciate how much easier this makes the world from like what I'm used to historically. Like the amount of engineering and overhead and sort of complexity that we managed ourselves at Netflix in order to get our streaming Kafka topics into Iceberg tables. We had all this Flink infrastructure. It was a lot of moving parts in order to get it performant and low latency. And now, with platforms like StreamNative and Databricks, you're talking about just configuration, like a few properties, and all of a sudden, all your streaming data is available for analytics, at low latencies with exactly once guarantees and all these things that are very difficult to achieve. So it's a brave new world. It's really exciting to see all this stuff come together. And it sort of looks simple to demo. There's a lot of complexity in making all this stuff work, but it's really powerful. So really cool to see.
Awesome. Sounds great. Well, thanks a lot, Jason, again. And thank you all for joining. And you all have a great rest of your day. Thank you.
Thank
Bye.
you.